All right, so I wanted to go through some of these proofs just using the algebraic definition. So I'm going to just use the formula from the textbook. You could also do it with the using the determinant of the matrix. Works just the same either way. Um, so let's just pull it straight from the formula about the vector product. All right, here we go. And so when we look at problem one, we're just trying to prove that A cross B is the opposite of, B cross A. So A cross B looks like this. We go A2 B3 minus A3 B2. Then we go A3 B1 minus A1 B3. And then A1 B2 minus A2 B1. That's A cross B. Then in a different color, I'll do B cross A. So all I'm going to do is write the same definition down, just swapping A and B. So B2A3 minus B3A2, B3A1 minus B1A3, B1A2 minus B2A1, and voila, if you notice that the component here times -1 matches up with each component down below. All that happens is we switch the order of subtraction, and we're basically using the idea that A minus B is equal to negative B minus A. And that's true for real numbers, and each of the components of the vector are real numbers. And so that concludes the first proof. And that's all there was to that one. So for the second proof, we're going to go ahead and just tack on vector C here. And so we will take A cross B, which we already knew, and we're going to cross that with C. And so C is just going to be C1, C2, C3. And so let's look at the formula and try to figure out what the heck's going on here. So I'm going to erase a little bit just to clear things up. Okay, so now what I'm going to do is, this is like our first component. This is like our first component. This is our second component, and this is our third component. And so when I write this out, I'm gonna write it in terms of x1 and c1, like an x and c. So A cross B crossed with C is gonna be x2 c3 minus x3 c2. x3 c1 minus x1 c3. x1 c2 minus x2 c1. Come on. And I'm just using the x and c's because I want to make sure that you see I'm just using the same cross product formula again. And then what I'll go through and do now is substitute what x1 and x2 and x3 mean. And what I'm really trying to get to, by the way, it's always good to keep in mind your goal is to get to this minus this. And so it might be a good idea just to remind ourselves that A dot C is going to be A1 C1 plus A2 C2 plus A3 C3, and A dot B is going to be A1 B1 plus A2 B2 plus A3 C3. And I'm going to have the A dot C is going to be multiplied by each of the components of B, and the A dot B is going to be multiplied by each of the components of C. So let's see if it pops out that way. So let's substitute in what the x2s and everything stand for. This is just a lot of writing. So let's see if it works. Okay, so x2 can be replaced with a3 b1, and that's times c3. I'm just going to distribute, minus a1 b3 c3. Then we subtract x3 times c2. So that's a1 b2 c2 double minus a2 b1 c2. Same sort of strategy on the next one. We have x3, the bottom row from over in this matrix, that bottom row, times c1. So we go a1 b2 c1. I'm distributing, minus a2 b1 c1. Then I have x1 times c3. So I have x1 goes a2 b3 c3 double minus uh, a3 b2 c3. Almost done. Let's move this out of the way. Now we have x1 times c2. So x1 becomes a2 b3 c2 minus a3 b2 c2 minus x2 times c1 a3 b1 c1 double minus geez, okay, a2 b1 c1. Okay, what do we got here? So we want this to be the same as a dot c times b. And so a dot c uh, times b means we should be able to collect a b1, all the b1s, all the b2s, all the b3s. And so I'll pull out b1, b2, and b3, and that should be multiplied by a dot c. And so from the very top problem, I notice b1 is here and b1 is here. And so I notice that it is attached to a3c3 plus a2c2. And then on the second component, I see b2 there and b2 there. And so I get a1c1 plus a3c3. And then b3 on the bottom is attached here and should be here. I must have miswritten this. Should have been b3. And so that's the other piece there. So I have a2c2 plus, this must be a1c1. And that looks pretty good. Then I do the same thing with the C components. And so I'm looking for the C components and the dot product of A and B. And that's interesting. I'm not seeing it show up that way. Interesting. What are we missing here? Okay, so what we're missing is, all right, so this is not the full dot product. Okay, this is interesting. I thought it was going to pop out. So we don't have the full dot product right here. So I'm going to do a little bit of wishful thinking, and I think this will work out. I would like to add in the missing component, A1C1. Now I've completed that dot product. A2C2, I've completed that dot product. A3C3, I've completed that dot product. But if you add in an extra term, you also need to subtract that term as well. And so I'm subtracting at the same time A1C1B1, and I'm subtracting A2C2B2, and subtracting A3C3B3 to keep things all aligned there. And so let's see if that works. Does that work? Interesting. I'm not seeing it working. How does this work? Is it possible that this formula is wrong? It is so possible that this formula is wrong, isn't it? Oh, this is funny. Yeah, this is a typo. It's just not true. Okay. I'm looking at a different formula sheet and it has it written differently. So that's kind of fun. So, okay. Great video here, Mr. Maurer. There's no way that I can make it equal A dot B dotted with C, A dot B times C, because the problem is I don't have. Okay, so here's the problem. No matter, even with when I do my wishful thinking that I did over here in the bottom right, this was, I'll put it in pink because it's a wishful color. Even when I try to do this wishful thinking here, there's no other, like, if I wanted to get C here, there's no other C1. There's no C1 in the top component. There's no C2 in the middle component. There's no C3 in the bottom component. So there's no way I can even like compensate for it or make it work. And in the chapter review, they have the second property written out very differently than the problem number 4. So yeah, I apologize about that. But I guess the point of this video is that this cannot be proved. It happens to not be true. But the first proof was pretty straightforward. I'll pause this video. I'll make a separate video for the other ones, and hopefully that one is correct.